I've been focused on Blazor for about the past 4.5 years. And there's some exciting new technology coming that lets you deploy Blazor to the desktop and mobile. And I want to talk about the future of cross-platform Blazor. There's a couple different ways to actually do this. And the idea of this session is to show all the different ways that we can get desktop and mobile with Blazor and give you the ammunition to kind of make the right decision of which platform to choose to go cross-platform Blazor. And before I get started, I do have a lot of demos where I zoom in on code and zoom out, and it pans around the screen a lot. So if that type of motion bothers you, just a heads up that that is going to happen. Just like to let people know, because there's some disorders and things out there that can really throw people off when they see that. So first we're going to talk about Blazor on WebAssembly and responsive web design. Then we'll move into progressive web applications. We'll talk about Blazor Electron, and then finally we'll talk about .NET MAUI and Blazor Hybrid. So this, we're trying to target everything, web, desktop, and mobile, iOS and Android, Mac OS and Windows, all from one single code base. It's like the multi-platform of madness out there. There's a lot of different targets to hit. And one of the ways that we can do that is just by making our Blazor applications responsive. So I'm a big advocate of responsive web design. I've been talking about it for what feels like nearly 20 years now. It's like probably 10, 11 years now. We've had responsive web design so we can tackle these different screen sizes. And I'm going to also throw in a quick overview of what Blazor on WebAssembly is for those that may be new to Blazor here as well. So Blazor is a web technology that runs in the browser, and it uses .NET technology to do that. If we look at how the web generally works, we have JavaScript that comes in to the browser. The browser parses and compiles that JavaScript, turns that into bytecode, and then it interacts with the browser APIs. With WebAssembly, what we've kind of done is given another interface to the browser here for that bytecode. So we're able to use bytecode that's been compiled externally from the browser. This kind of circumvents JavaScript, and we can use other languages like C# to compile things down to WebAssembly and run them directly in the browser. And that's what Blazor is. Blazor is a framework that is working on top of the .NET runtime. The .NET runtime has been compiled into WebAssembly, and the .NET runtime is now running in the browser, and we can compile and execute .NET libraries right inside the browser. This gives us the option to use a lot of .NET technologies, tools, NuGet packages to do web development. So we're kind of bypassing JavaScript here. Now, something that's really important to all of these different deployment modes I'm going to talk about is how that execution happens. So a typical Blazor WebAssembly application runs actual .NET executables on the .NET runtime that's been compiled to WebAssembly. So you're not transpiling your code or compiling it to WebAssembly. It's actually running .NET DLLs. And it does similar execution on the desktop, but there's one key difference between desktop .NET runtime and the WebAssembly .NET runtime. And that's the desktop uses just-in-time compilation. Now, the browser uses more of an interpreted mode. It's a limitation to WebAssembly and just how that works on the web. So there are some speed considerations that you might need to think about when you build a Blazor application. Now, the performance that you see with Blazor is great for things like web UI. If you're building charts, graphs, data grids, dashboards, things like that, it's more than sufficient performance for you to build those type of forms over data type of things. If you have something that is really taxing, like maybe you're trying to create a PDF on the fly, Telerik has a library called the Document Processing Library. We typically tell people not to use those in WebAssembly on the client. You want to put that heavy lifting stuff on the server, put it behind a web API, do your PDF generation or whatever type of heavy calculations you're doing on the server side, and then send that data down when it's finished. Because Blazor or .NET, the .NET runtime in WebAssembly just isn't efficient enough to take care of those heavy lifting tasks. This is important because some of the deployments that I'll show you circumvent the WebAssembly part of Blazor and actually let you use .NET runtime that's local to that device. So I advocate heavily, again, for responsive web design. And Blazor is a web technology. It uses HTML and CSS. And you can build responsive websites with Blazor. This is an example. It's a demo application that I wrote using some of our components from Telerik, just some regular Blazor code and best practices for responsive web design. And if you visit this website from web, desktop, or mobile, it adapts itself to those technologies and renders a UI that's comfortable to use on all of those devices. So with responsive web design in Blazor, we can get to all of those devices based on their screen size, but there's some things that we're missing. We can't publish those apps to the App Store. That's not something that you can just do with a web application. So there's no desktop screen or desktop icon or home screen icon. And you don't have access to device hardware APIs. So you can't read the file system on those devices. And again, you don't have the full speed of the .NET runtime because you're using WebAssembly. So there's a little bit of a limitation there. So next we're going to look at progressive web applications. So we're going to kind of take the responsive web app and give it some more abilities to try to get it more desktop-like. So a progressive web app uses service workers, manifest files, and other web platform features to enhance the application and make it more desktop-like in an experience. And one of the main attractions to the PWA is that our web application becomes installable. So this gives it that home icon or desktop icon that we're looking for. They also get to be a little more discoverable because you can submit these to app stores. And the main requirements to make a web application into a PWA or progressive web app is that it has a manifest file. This is a file that kind of outlines all of its static resources, that desktop icon that I was talking about, those type of things. They have to be served over a secure network. So you need a HTTPS website. You should all be doing that these days anyway. But it does have to be secure to be a, quote, PWA. It needs the icon to represent the app on the device. And it needs a service worker registered to make the application work offline. Now, offline mode is a little bit of a gray area with this. To be considered an offline capable app, there were some loose recommendations made that at the very least, your application has to show a screen that says this feature doesn't work when the app's offline, instead of just crashing or not working. They were going to tighten that down a little bit more. When I say they, like Google, the W3C, but they've kind of loosened that terminology up. So you basically have to let users know that you're offline, and, exit gracefully type of thing. Now, service workers are JavaScript code that's running on separate threads in the background with the browser. Mainly, they intercept network traffic, and they do this to cache data for that offline mode that we were talking about. So they'll get and set cache quite often, and they'll also have access to do things like deliver push notifications. So these are technologies that we're using to make it more desktop-like. So we're looking at adding the platform technologies here, and there's a lot of things that we can do with service workers and just web APIs in general that give us that desktop feel. We can access a lot of these APIs in the browser, and if you go to whatpwacando.today, I believe that's a Mozilla website, you get this app, and it's installable because it's a PWA. You can install it right on your desktop or your mobile device, and then try the demos of all these different APIs that are available in the browser. You can do some really cool things here, like authentication. It'll actually pop up like the thumbprint authentication that's available on your device. You can do augmented reality, payments, all sorts of amazing things that you might not think the browser is capable of doing. You can actually do with PWAs. I did forget to note here, though, that JavaScript is required for most of these things. Blazor being a .NET and C# technology, you're still going to have to fall back to JavaScript to access a lot of this stuff. So I'm going to do a quick demo of a Blazor PWA and how you can create a progressive web app from scratch. It's actually a pretty easy process because they've baked this functionality into Visual Studio and in the .NET templates you can also access from the command line. So I'm going to start a brand new Blazor project here. I'm going to go with a Blazor WebAssembly app. So we'll select that template. You can ignore the name. I've done this demo quite a few times, so you might see a familiar conference or whatever in the title there. But the main thing is you want to select Progressive Web App from the template. When you select that box for a progressive web application, this tells the template to generate those manifest files and things that you need for this to be a progressive web app. So once the template is created, you can see we have a manifest.json file, and that has things like the app's name, the icons that are going to be displayed on the desktop or home screen, and there may be some other data in here like background colors, things like that. It doesn't replace a web config. This is a progressive web app standard. So this is something that if you're going to submit it to an app store that Google or Microsoft or Apple is going to be looking for to kind of describe what that app is. It will also generate service workers. So you'll see a service worker JS and a service worker published.js. So there's a little bit of funny business with caching that happens in a PWA because it's trying to have that offline mode capability. You really can't debug that stuff without publishing the app. So you're going to write all of your actual code in the service worker published JS file. The non-published JS file is kind of like just a placeholder to satisfy the fact that it needs a service worker. It generates both of those files for you. And when we go to the service worker published file, you'll see it's got a lot more going on inside of it. So these are events that are happening with your application. There's things like on activate, on install, on fetch. These are all events that you can write custom code in to do things to make your app work in offline mode, for example. So that's all templated out for you with the Blazor PWA application template. So that one little checkbox gives us a good running start. Then once we have our application, if you've ever seen a Blazor Hello World app, it looks very similar, but this one has an install button. So we can install this on our desktop. We can also install it on a mobile device, and you'll notice the browser drops away, and it looks just like a desktop application. We also get some additional benefits, like at the bottom of the screen, you get like the hover effect. You actually have an icon on the bottom of the taskbar. You could uninstall the application if you want to. We're going to go ahead and close this one or pin it to the taskbar so we could find it later. If we go ahead and close the app down, it's pinned to the taskbar, so I can just open it right back up. This is quite a bit different experience than going into the address bar and typing in a URL. And then once we're done with the app, we can uninstall it. So that gave us a couple more things that we didn't have with just responsive web. PWAs let us publish to app stores. In light text there, you probably see platform support may vary. Apple's not a big fan of these, so some things don't work on the Apple platform. That's constantly changing. They're getting a little bit better as time goes on, but you might want to read up on those specific platforms before you publish. We did get a desktop application home screen icon, so that's nice. We do have device hardware APIs available. They're not necessarily the native platform APIs, but they're very similar and do functionally the same type of things. We're still running in Blazor WebAssembly, or .NET WebAssembly, the runtime running in the browser, so we still have that performance issue for long-running, heavy lifting tasks that we haven't dealt with. The next thing I want to talk about is Blazor on Electron. So we're going to step this up again one more time. We're going to take the Blazor framework, put it inside of an Electron application, and use that to target the desktop. So let's take a quick moment to talk about what Electron is. So Electron is a framework that lets you build cross-platform desktop applications using JavaScript, HTML, and CSS. And there's a lot of really popular apps I'm sure many of you are familiar with, like Visual Studio Code or Microsoft Teams. Some of you might use Figma. These are all Electron applications. So this is building some pretty popular and big stuff. And Electron works by taking Node.js and packaging that inside of kind of a shell with this thing called an IPC. It's a intercommunication protocol channel, I believe is what that stands for. And it can talk to one of many rendering processes that use Chromium. So it's kind of packaged up in a desktop app, but it's using Chrome to display the UI. It does have access to the operating system, and it does have some platform UI with it as well. So you can do like native platform toolbars with an Electron application. But we're building with .NET tools. We don't necessarily want to write JavaScript, because you can see Node.js, that's a JavaScript technology. We're .NET developers. We want to use Blazor. So we have Electron.net. Electron.net is a wrapper around Electron.js. And this gives us .NET APIs that we can access that call down to the JavaScript framework abstracted away from us. So we can build our desktop applications using Electron.net, and we can use Blazor with this as well. The reason this works is because with Electron.net, we have that Node.js main process, but we also have a .NET process that's communicating across the IPC. Since it is a .NET process, that means we have the full .NET runtime of that device. This is not WebAssembly. We also have a render process working in Chrome. And because this is an ASP.NET Core server, we actually have access to Blazor Server. So this is going to actually render and execute code much faster than a typical Blazor WebAssembly application, because it has these technologies embedded in it. And it also has access to the operating system and some platform UI. So that sounds like a lot of complex stuff. If we look at the block diagram, it's like, how do I even build something like that? I thought this was going to be terribly hard. Turns out it's not that hard. So I'll show you how to do a quick demo with it. So we're going to start off a new project again. Unlike last time, we're going to select a Blazor Server application. The reason we're choosing Blazor Server is because we don't need WebAssembly here. We have the .NET runtime through Electron.net. So we're going to start up a new application. We just have to give it a name. .NET 5 is the currently supported version. Last time I checked, that Electron.js or Electron.net can use. So they haven't quite got to .NET 6 yet. I know .NET 6 is LTS. .NET 5 is still the last generation of .NET. I don't know what the timeline is for that, but it is something to be aware of. So we have our brand new application. I'm just going to go ahead and run this. This is still not an Electron app, but I just want to show this is Blazor Server. It's the basic Hello World demo. We've got our counter and our fetch data. This is familiar territory if you're a Blazor developer. The next thing we want to do is convert this server application to an Electron.js app. So we're going to need some dependencies here. We'll go ahead and add some NuGet packages. So there's actually one package that we'll add to our project directly, and that's going to be the Electron APIs. So we need our Electron.net APIs. And you'll also see a second package in here called Electron.net CLI. That is installed at the command line at the global level, because there's some command line tools that you need to execute the first build of the Electron application. And we'll do that at the end. But just to make note, this was installed on the command line globally. Okay, once we have those packages installed, we need to register some services. So the first thing I'm going to go do is in my create host builder, right above use startup, I'm going to say use Electron. This is essentially telling the application to go ahead and add the resources it needs to start that that Electron application. And then we'll go into startup CS, and we'll go ahead and register any dependency injection and services that we need for the Electron APIs as well. So we'll do add Electron here in services. So far, not bad. We got 2 lines of code here. Just need to add any using statements to bring those items into scope. And then last but not least, we're going to tell the app when it boots to go ahead and start that Electron application up. So we'll say task.run. Electron window manager, create a window async. And that's going to boot that native application up on the desktop. Now, once we have all that configured, we need to open up the terminal, because remember I said we had some command line stuff that we have to run. That's at the global level. We need to call the Electron API or Electron CLI and say electronize.init. And that's going to create what essentially is like a package.json file, if you're familiar with JavaScript terminology. That configuration file tells the Electron app where its resources, dependencies, and stuff like that is, much like package.json does. And that's going to convert our application then from server to Electron.net. So that's the final step. We now have an Electron.net application. So up in the top, Visual Studio actually recognized this, and it went from a server application. It now says start Electron.net. When we start it, it will actually do npm installs. It's taking care of that JavaScript stuff we don't really want to touch behind the scenes. You can see it doing the npm install, npm start, that type of stuff, and then it will boot the application up. And now we have a Blazor application that is running as a native desktop application. So this is web code, but it's being presented by this Electron shell. So we have access to everything. It's not using WebAssembly anymore, so we've got a little bit more speed. We can access the full capabilities of the .NET framework on that device. So let's make this a little bit more interesting. Let's add some more stuff to it. We have access to the system now. So we're going to go into index.razor, and let's go ahead and add some platform-specific code here. Let's do something with the access to the native device that we have. So we'll jump into the top of the page, and we're going to add some using statements here to bring in that Electron API. So I've got system.io, which is part of the .NET ecosystem already. That gives us file access. And then Electron APIs are going to help us with some of that file access. So remember, we're targeting Mac desktop and Windows desktop. So there's going to be some things that are similar but different on each platform. So we'll deal with that. We'll write some Razor code here. We're going to loop over a list of files. And then we'll use system.io to say path get file name. We'll pass in the full path of the file, and it will take off everything but the file name and give us that output. In the code block, we just have an array of strings. That's going to hold all of our file names that we're getting from the file system. And then on initialize, we'll just go out to the disk and read those files. So on initialize, we're going to call an Electron API here It says Electron app get path async. What this is going to do is normalize between Mac and Windows what this path name is, because they're very different operating systems. So when I call path.documents, pathname.documents, this is going to get what is the equivalent of the My Documents folder on Windows from the Mac device. And if it's on Windows, it'll be My Documents. So we'll go ahead and do that. Once we do that, we can use system.io from .NET, and we can say directory get files. That's going to give us all the files in that directory that Electron gave us. So once we do that, we'll bind to that data using a little bit of HTML there and Razor code. So we can rerun the application. And when the application boots up, it will immediately, because of the onInitialize function, when that page initializes, it's going to read all the files off disk. So there's a list of all the files on my Documents folder that this application is running on. So we're gaining some new ground here. We can actually have a desktop application and access our file system and many of the other APIs that come along with the Electron.NET wrapper. So we've checked off some more boxes here. We can publish to app stores, because this can compile to a native application for Windows and Mac. We have icons with that. We have device hardware API access with this. We can read file systems and other sensors and things that are on those devices. We have the full speed of the .NET runtime here. One of the boxes that just came up, though, is we can't deploy this to a iOS or Android device. Electron.NET has kind of a reputation of being very memory intensive. So if anybody's run Slack or Teams, you probably know this. It can eat up some RAM pretty quick. That's not something you want to do on a mobile device. You're going to ruin somebody's battery. It's not advised. It's possible through some third-party extensions and things, but there be dragons. So I say desktop only. Another thing I want to point out is it's a bit of a niche ecosystem here. You're talking about a framework within a framework within a framework. There may be people that do Node. There may be people that do Electron. There may be people that do Electron.NET. I don't know how many developers you're going to find that do all of those things and Blazor. And if you go searching on Google for these things, you're not finding a lot of blogs. There's not a great deal of documentation. That sort of thing is pretty limited. Even though it's pretty easy to boot up and get running, if you run into a problem, it might be a little hard to solve. So we're going to talk about the last technology here. And this is probably the most promising one in the bunch, but it's still worth talking about all the other ones. They give us different ways of tackling this issue. But Blazor Hybrid with .NET MAUI seems to be a really nice path to take. So this is .NET MAUI, or a multi-platform app UI. It's a cross-platform framework, and it shares a single code base to deploy to all these platforms because it's a successor to MAUI, or Xamarin is it's a successor to Xamarin. So this is like the next generation of Xamarin. We have MAUI now. And MAUI gives us the ability to deploy to desktop and mobile. So the only thing we're missing here is web. So if we include some Blazor code, we might be able to deploy everywhere. And with .NET MAUI ships something called the WebView 2 control. And then there's also a spinoff of this called the Blazor WebView control. So the WebView 2 control that ships with MAUI is an embedded web technology for MAUI. And it uses an embedded Chromium, embedded Edge Chromium on Windows. I believe it actually uses the Safari engine on Mac or iOS. And it uses this to display web content inside of a platform application. So Windows, desktop, and mobile. Some interesting things about the WebView 2 component or control is that we can use it to wrap the entire UI of the application, or we can just segment off pieces of the UI that we want to use this for. So we can mix and match platform UI and web UI in the same view. It's evergreen distribution or fixed version. You can choose either or. There's been these embedded web view technologies for a long time, and usually they fall into this trap of not being updated. So you have security issues, things like that. Well, this has an evergreen option. I think that's the default. You actually have to opt into the fixed version if you want that for some reason. Is that? OK. It supports Windows 7. So it's not exclusive to MAUI. You can do this with WPF or .NET or the desktop framework as well. So WinForms can do this as well. And the way it works is you have a MAUI app, and you have a WebView 2 component, a Blazor WebView component inside of that controlling the UI. This gives you access to all the platform application stuff because you're running inside that MAUI ecosystem. So let's try to do a quick demo. We're getting short on time here, but we'll try to get this spun up. We're going to do a new .NET MAUI Blazor application. So this is a whole template that comes with Visual Studio or .NET now. It was in preview at the time I recorded this. That preview is now over, and it is officially released. So go ahead and spin up a brand new application here. And you'll notice some similarities between a normal Blazor WebAssembly or Blazor server app because this is essentially a Blazor application. So we have things in our folder tree here, like our pages folder has an index, a counter, fetch data. These are the same samples we see in all the Blazor projects. They are exactly the same components and Razor code that you see in those other projects. There's nothing in here that's different, even code-wise, from those examples. We also have the ability to use CSS. This is still HTML and CSS to create our applications. And we do have an index HTML to bootstrap that web view. So the web view, I'll show you in a moment here, will actually call out to this index HTML page and load that up. And we have that the same bootstrapping that we have in Blazor Server and Blazor WebAssembly. The only key difference here is it uses a different script file. It says Blazor WebView.js here. If you're on Blazor WebAssembly, this would be Blazor.webassembly.js. But since this is using Blazor WebView, that tells it can use the device's .NET runtime to execute the code, and we don't have that performance issue with Blazor WebAssembly. So we could do PDF generation, image manipulation, all that type of heavy lifting stuff right inside of our app. We don't have to host that out on a server somewhere. Inside of app.xaml, this will be kind of the bootstrapper for the XAML portion, the MAUI portion of the application. And then we have main page.xaml, and this is like the first view that gets loaded with the MAUI app. And inside of that view is a Blazor WebView component. That's that WebView 2 control that I was talking about. This one has some added Blazor technology to it. It comes out of the box with MAUI. It has a couple of special properties that apply to Blazor. One of those is it has a host page property. That host page property tells it where the bootstrapper for the application, the Blazor application, is going to be, and that's our index.html page. So this is what controls that boot process of the Blazor app. It also has a root component with a component type selector that points out the Blazor component that will be loaded into that web view. And this is going to be main.razor. And main.razor is the router for a Blazor application. This is very similar to app.razor in a WebAssembly app. So these are essentially the same code that you'd see in app.razor. So this is how your Blazor part of your application gets booted up. And then there's a few things that are slightly different from the Blazor MAUI or Blazor Hybrid application. We do have our pages, components, www root folder, and so on, but you'll also notice that we have a platforms folder that I should be outlining here in a minute. The platforms folder is a special folder that holds code specific to platforms that we're targeting. So if there's some type of boot up routine or some type of code that we need to write specific to iOS, Android, Mac, Windows, we can put it in those folders and create alternate code paths and execution for those platforms. There can be different resources embedded there as well, images, fonts, those sort of things. You can use that platforms folder to help control and organize the code for those platforms and resources. So up at the top here, you'll see we have different platforms being targeted. And we're about out of time here, but when we drop this down, this is where we get all of our devices that we can load here with Android, the desktop, and so on. We can mix and match these UIs, platform and web. And we can also take the components from our Blazor application, put those in a third project solution, and host those with Blazor WebAssembly or Blazor Server. Because essentially the components in Blazor, they can be used in any of these devices as long as they're fetching data that's agnostic to those platforms. So you might need some alternate code paths to work on around things like file access when you're on the web. You don't have it, but you can inject services and things that can compensate for that. So we get pretty much everything that we need from Maui. The only thing that we don't have yet is Linux. It's something that's being worked on. I think there's a community version of that out there. So if we're going to compare these together, there's the ability to publish on the store to all these PWAs, somewhat limited. We have access to platform APIs, except for with PWAs, we have to go through JavaScript to do that, and it's in a JavaScript sandbox. PWAs use WebAssembly, but the others use the platform's runtime. PWA can hit Linux. That's one that we're missing from Blazor Hybrid right now. And Blazor Electron is missing mobile. So we've got some things there. You also see Quest in there. You can deploy some of these apps to the Quest as well. And I've got some additional resources here that you can view, links to a recording of this talk and so on. Just hit up that bit.ly link. It'll take you to my website, and you can find all the links there. So we kind of ran short on time. I had some more demos to show you, but if you catch me around the conference, you want to know more, just feel free to ask. Oh, do I have a few more minutes? Oh, OK. Got about, what, 5 more? OK. So let me circle back for a second to show the second demo here that I wanted to get into. I actually have, oh, it's not projecting. Let me get the no. Doesn't want to show my desktop there. All right, so I've got a WebAssembly Blazor application running here in the browser. I also have it running natively on Android, and I also have it running natively on Windows desktop. All 3 of these deployments use the same code base. So just real quick, I wanted to show how that actually gets done so we can deploy to all the platforms that are available to us. Inside of this app, we've got the Blazor WebAssembly client. We've got our Blazor Hybrid that gives us desktop and mobile. So the first one is web. The second is desktop and mobile. The server is serving API data. It's not necessarily serving, it's not rendering any views to the desktop or mobile versions of this. It does serve the index.html page out to the browser, but it doesn't render anything. It's just mainly there for web API and static resources. We have a shared solution here. That's any shared logic. This is all .NET up and down the stack, web, desktop, and mobile. So any CS files, classes, things like that we can share across all the projects, we can put there and reference from any of the projects above. And then finally, the last one that we have is called shared UI. Now, shared UI has nothing but components and pages that we want to use in our web, desktop, and mobile applications. This is what's called a Razor class library. So it has all of our UI in it, including our pages. And because of the way Blazor handles routes, the routes are in the pages as well. So if I go into my client application, you're not going to see a pages folder here. It's getting the pages and the routes from shared UI. And the same thing for Blazor Hybrid. There's no pages folder, there's no components folder, no shared. It's getting all of that from shared UI. So both of those projects have dependencies on that shared UI. And because they're all using Blazor, they can use any Razor components that they find in shared UI. The way that gets set up, the main piece that you need to look for is in either app.razor on WebAssembly or main.razor in Blazor Hybrid. These are both the routers for those applications. And the router has a property on it. See if I can get it into full view here, called additional assemblies. So when we tell the router to go look at the additional assemblies of the shared UI project, it will then pull in all of the routes and all of the components. And now we don't have to duplicate that code in our hybrid application or a WebAssembly application. We can write all of our shared UI in one project and then share that among any Blazor application that wants to consume it. So now I can use those pages and components in anything, and now I can deploy to web, desktop, and mobile without repeating a bunch of code. So a great future that we can do all of these different things from one code base. There are some small things to consider when you're building any type of mobile application, and you're going to find these type of hiccups no matter what platform or what framework you're working with. So some of the things that you might run into is if you have an ASP.NET web server and you're running an emulator, the emulator is not on the network that the server is on technically. So accessing the APIs that you're writing when you're debugging things can be a little bit difficult. So there's some alternate code that you have to use during testing, or you can use third-party VPN type services that can kind of host your local machine on a port forwarding type of a situation where your emulators and your test devices and things can access your local host. So you're going to run into some little tripwires that are just common with mobile development more than it is a hybrid thing. So there is that to watch for. But other than that, the Blazor process of it is pretty smooth. I also had a demo I cut short here too. Similar to the Electron app, we can use it's almost the same exact code minus the Electron API. Now we can access those the file system the same exact way. The code is spot on, almost the same. One other caveat there is when you say something like My Documents in a desktop application, that's a space that your application has access to. When you're on mobile, it's sandboxed. So if you say My Documents, you're going to get different, some varying things happening between platforms. You're going to get a read on your Windows machine off of My Documents. The Android device has a sandbox for that app, and it will create a folder that is the equivalent to My Documents in the sandbox. So you're going to have no files in there unless you create them, because they're specific for that application. It doesn't have like root access to your file system. So you'll see a little bit of things in there that are very mobile specific to watch out for, and I think you're going to hit that no matter what cross-platform framework you're dealing with. But I think that's about it. Some of those things are covered in the resources. So thank you very much. I'll take questions as we kind of disperse here, but if anybody needs to know anything else, I'd be happy to kind of take those offline.